Regenerative engineering is the convergence of advances in material sciences, stem cell and developmental biology, physical sciences, and translational medicine to develop scalable tools that will enable the regeneration, restoration, preservation, or augmentation of tissues and organs in order to restore function.
I'm really excited about the Querrey Simpson Institute for Regenerative Engineering at Northwestern. Of course, it was spearheaded by Dr. Guillermo Amir. I've been working with Guillermo for many years now because of his great interest in wound healing. But he founded CARE 6 years ago, and that laid the foundation for research in regenerative engineering at Northwestern.
These are very exciting times. Regenerative engineering and regenerative medicine are very, very impactful fields that have the potential to change healthcare, have the potential to change and transform the lives of patients that typically have lots of morbidity due to the loss of a limb, amputation, an organ that has to be removed or not functioning, or people that are on waiting lists to receive an organ.
The only way to address this need is through convergence between a variety of sciences. We need to bring together biomedical engineers and physicists, computational biologists, clinicians, other biomedical researchers, AI. Everything has to work together. This is the essence of convergent science.
Vascular disease is atherosclerosis or plaque buildup in a variety of locations throughout the body, in the arteries in the body. And every day I have patients ask me, do you have a special technique to dissolve the plaque? So if we can find techniques, either with materials or translational research, to actually actively dissolve the plaque and restore the blood flow back to normal, that'd be great. So I think having the time where our young trainees, residents, and fellows can spend doing research with the biomedical engineers and getting them started on a career in research would be extremely helpful.
We can do research and projects that just 10, 15 years ago were not possible, where you would mix cells engineered from a skin sample, turn them into, for example, bone or muscle or adipose tissue. Working with leaders in bioelectronics, such as Professor John Rogers, the director of the Querrey Simpson Institute for Bioelectronics, we can now create unprecedented technologies that integrate advanced material sciences with bioelectronics and potentially cells and drugs with Professor Jonathan Rivney, for example, to deliver the types of technologies and products that we actually need to help preserve limbs, preserve organ function, or restore organ function after a significant traumatic event.
A lot of our work has involved soft electronics that interface with the surface of the body or implant into the, inside of the body to interface with internal organs to sort of monitor, physiological processes that could be indicators of health. I think there's a really powerful opportunity to take some of those platforms and add more therapeutic function to them, blend them with advanced materials to really address key challenges in regeneration of tissues. So not just monitoring tissues, but actually accelerating processes of regeneration. Ultimately, I think, the kind of success that we're looking for is in a translational domain. So not only education, scientific discovery, but also engineered systems that can move out of an academic setting into the real world.
Now we're using plastic devices when we do liver transplants and kidney transplants to stent open, using catheters to stent open things like bile ducts and ureters. These things have to be removed eventually by procedures. But we're working with RENU to form biodegradable products within the body so these things biodissolve over a period of time, keeping somebody from needing another procedure, for example.
We're beginning to develop absolutely futuristic applications that not long time ago could only be considered as science fiction. It should really be possible to regrow and regenerate cartilage and muscle. We are pursuing applications in cardiovascular protection, preventing devastating outcomes of ischemia and infarction.
There are many people here at Northwestern who are so excited about the opportunity that RENU will bring in allowing for convergence of specialists to not just talk engineering, not just talk medicine, and not just talk about the biology, but to bring everyone together into the same room so we can get ideas going for what the needs are for patients, actually bring these ideas to fruition at the bench and then bring them back to our patients and make a difference in their lives.